let me ask a couple questions. You can answer any one of these. So it's 4 questions, answer whichever one you want. Number 1, is there such thing as a way to suck CO2 out of the atmosphere? 2, would eating organic help because of the bad greenhouse gases that are in fertilizers and pesticides? Third, are you saying that did you say that if we really wanted to, we could be using renewable energy 100% in 5 years? Is that realistic if we had full cooperation? Is that really that we have the technology, we know how to do it? And 4, is it too late? And if it's not, when will it be? So one more time. 1, can we suck out the CO2 out of the air? Is there such thing? 2, would eating organic help so that we don't have to use these fertilizers, pesticides, chemicals, insecticides that contribute to fossil fuels, that contribute to greenhouse gases? 3, are you saying that it really is possible with the will, if we had the will, that in 5 years we could be 100% on renewable energy? And 4, is it already too late? And if it isn't, when will it be? So if you can answer any of those.
Carbon sucking? My understanding is that it's just not there yet. There's been a lot of work on it, but in terms of massive capabilities to do so is just not there yet, but I could be wrong.
No, you're right. We have zero capacity, right? Today we have zero capacity to take CO2 out of the atmosphere. So we got...
Trees.
Sorry.
Yeah, I mean, there are natural ways that carbon gets sucked out of the atmosphere, and those are trees, those are algae, plankton. Now, whether we want to seed the oceans with iron and fertilize them so you have massive plankton blooms to suck up carbon dioxide, scientists have looked into that. It seems incredibly dangerous. Think of talking about the possible unintended consequences. But if you want the cheapest, easiest answer, more plants. We'll leave no rooftop left behind act. So all rooftops everywhere could be covered either with green space gardens or solar panels or solar water heaters or something. Use that space to do something good. But as for there's scientific experiments, big things you can erect that suck carbon out of the atmosphere, incredibly expensive. There's other technologies, the so-called carbon capture and storage, that you can inject the carbon dioxide into the ground or into deep sea formations. Again, not necessarily permanent, very expensive, and why not just avoid putting it there in the first place, leave it in the ground? But no, there's not a cost-effective machine we can put out there that will start taking carbon dioxide any better than nature has already made.
Can I just build on that? I think, obviously there are these things short of geoengineering, which I agree we don't want to pursue for unintended consequences, but reforesting deforested places, carbon soil building through agricultural practices, zero-till, biochar, those things that make sense, and kelp bed farming, as I mentioned earlier. This coast was denuded of its kelp. That would be a storm surge protection measure as well as a carbon sink. We can do all those things very easily today, and they suck a lot of CO2. In fact, forest is probably mathematically the only thing that right now we have that does the numbers. But also, again, short of geoengineering or carbon capture and sequestration, which I think is another tool of obfuscation by the fossil fuel interests, there are ways we can reframe carbon dioxide from being a waste product to being a byproduct, and then using it for other industrial processes. And I realize this could feed the consumption machine and a bigger conversation we've been having here. But for example, my fund has invested in 2 companies in the last 18 months that take CO2, air-captured CO2 from the atmosphere, from the sky, and make useful products out of it. One is focused on graphene, a new compound that you've probably heard of in the scientific literature. So they take it from the atmosphere and turn it into graphene. We found them when they were able to do this. It's called Saratoga. You can look them up at the level of about a thumbnail per day. We've funded them sufficiently to maybe get that to a handful of graphene. Tiny quantities, nowhere near commensurate to the task of what you would put graphene to work to do. which would be in batteries and other industrial and electronic appliances, but it could be a really powerful solve if we were taking CO2 out of the sky and turning it into these things that we don't want to be digging up the ground for and so on. The other one is basically using carbon dioxide as a precursor to industrial chemicals through reformulation chemistry and using electricity as the input. So one of the realities of renewables is because they're variable, you have periods of curtailment, we call it currently, where we have surplus electricity, which I think is kind of a crazy idea that again we have to reframe. But when you're having too much wind and solar power being generated on the grid, rather than shunting it into sand, which we do in some places on Earth today, they take that abundant electricity and they take CO2 and they use it to create chemical reactions which produce other useful chemicals in combination with other raw materials. So they can produce, for example, carbon monoxide or oxygen or other things. That company's called Opus 12. You might have read about them in Vanity Fair. Are they economic? Yes, they are. They actually make those precursor chemicals to industry at a lower cost than where we get those precursor chemicals from for industry elsewhere. They have to prove that they can scale that, but they do. Similarly, the graphene production. But I think this is what I'm talking about. We can unlock the genius of innovation and invention and entrepreneurship, lift all boats, find solutions, and we can see CO2 in the sky as something we have to get rid of, and we do it through productive use.
There's two methods that have been talked about for years and years and years, and one of them is, which has been the most popular, is called bioenergy carbon capture and storage, which is burning wood and stuff. And anyway, the IPCC has sort of favored that, but they changed in the last 1.5C assessment, and they said that the research is saying that we need to move away from that, which I was very happy about. So the other method is direct air capture. Now, there is one example of that. I mean, it's a small scale, but it's happening north of Vancouver in my province of British Columbia. The research was done in the University of Edmonton, and yeah, they're getting CO2 out of the air, and they're making it pay because they're getting enough CO2 out of the air to make a fuel that they can burn. So that's interesting. The criticism of it is that it will require a lot of energy. So we're back in getting more energy, right? But I'm glad that the IPCC is going off the idea of burning up all kinds of wood and trying to capture that.
Yeah, the IPCC scenarios, they just put in huge negative emissions, which is very unrealistic, and they've recognized that. But we have to realize the magnitude of CO2 that we're pumping into the air, 10 gigatons of carbon per year. If you replaced all the forests, put forests back every place where we've deforested, you could get of the order of 100 gigatons, which would be 10 years of our emissions. So that can't solve the problem. We really have to, and in our paper, Young People's Burden, we costed with the most optimistic estimates for the cost, unless there's some magic that people can come up with, but it's unlikely because it takes energy. But it was hundreds of trillions of dollars. If we stay on business as usual, young people are faced with a task of extracting CO2, which will cost hundreds of trillions of dollars, which means it probably won't happen. There are various things you can do that make sense, like preserving old forests and reforesting marginal lands, and even one that I've been a co-author on is adding rock dust as a fertilizer, so that you speed up the weathering process, so the carbon ends up on the ocean floor. But again, the amount that you can get these ways boy, it just makes more sense to phase down our fossil fuel use. It's hard to, it's worth investigating these things, and probably you're going to need to do and want to do a lot of them if they make sense. But you better, in order to keep the job doable, we've got to phase down the emissions.
There's one emission that we've not mentioned, and Dr. Hansen published a paper in 2001 called Alternative Scenario, right, in which he talked about methane and black carbon. And as I understand it, the consensus among the scientists now is that black carbon, which is soot, diesel engines, so big trucks and ships, and also in the poorer countries, instead they're not being provided with solar cookers and things, so they're burning wood and charcoal and stuff. So as I understand it, and I'd like to hear what Dr. Hansen will know whether that's right, but the consensus is that it's second only to carbon dioxide in the global warming effect. So if it is, and we can control black carbon, that could make a huge difference.
Yeah, that turns out not to be right. You know, the second biggest thing is methane by far, and nitrous oxide is also large. Now, aerosols is a different story, which is not as well quantified. The gases, it's actually very well quantified. We can measure the changes in the gases, and we know the radiative properties. We can, you know, it's within 10% on each of them. But aerosols is more difficult, and it turns out that many of the black carbon sources are also organic carbon sources. And organic carbon works the other way. It causes a cooling. And so if you reduce the source, you're not actually reducing the warming. And also there's a factor called efficacy, and it turns out that black carbon has a very low efficacy, so that really you shouldn't hope for much there. But that doesn't mean we shouldn't reduce. There's certain places, like diesel engines, produce a lot of black carbon and almost no organic carbon. So it's worth getting rid of that. But we're not going to gain a whole lot that way.
Okay.
There are now lots of companies, probably a dozen worldwide, that are launching satellites so that we can have worldwide Wi-Fi available via satellites. Launching those rockets generates the soot that you guys are talking about.
Yeah, not very much.
Okay. I don't know. I just know it generates soot. And then I just wanted to respond, Steve, to your question about whether it helps to eat organically. I've read that only 1% of food available now is actually organic. So that means it is an incredible privilege to eat anything organically. And I don't know how to shift that except to maintain awareness that if you are able to eat anything organically, that's a great privilege.
Okay, so just to conclude, if everyone would give a 30-second closing statement on any final thoughts, very final thoughts.
Education. We need to educate our population, and I think that's critical.
We need to motivate people to find solutions, and we need to focus on solutions more than ever now, and pass laws, elect officials, and everybody do their part in whatever way they can do it.
Just thanks for you all being here to have a conversation. I'm sorry we didn't get to exchange many views with the audience, but with everyone here on the table and all of your life's work, and Steve for hosting us, I think it's really important that we have these discussions. I don't think it's done. I believe that through our combination and ingenious ideas and pursuit of those, and opportunity and a future and a strategy of hope, even if we intellectually cannot find it in ourselves, but deciding to be optimistic, we will be able to get something out of this and have a future that's worth living.
I agree with optimism and having a great vision for the future. I definitely agree with that. I believe that hope is action. We, collectively, I think we're all the hope, right? Because we're doing stuff. We're out there. We're talking about it. But on the other hand, I think the public has to hear that all three greenhouse gases that Dr. Hansen just mentioned, carbon dioxide, methane, and nitrous oxide, they're all increasing extremely rapidly, and that atmospheric CO2 is still accelerating. So we're in a dire Earth emergency.
I think we need to get our democracy to work in an honest way and and that does require also education. The assumption of democracy is not going to work if the public is not well educated. And that requires getting money out of politics. And frankly, I think we need a third party because our two parties have become so extreme. The extreme elements have taken control of both parties, even though 60% of the public is not in those extremes. So anyway, I don't have a recipe right now, but we've got to work on our democracy.
Yeah, that's what it comes down to.
We're currently in the early stages of a great, enormous transition. It's a transition that can bring us cleaner air, cleaner water, better functioning cities, a chance to appreciate what we need, which might be mobility instead of an automobile, or a way to cook food and feed our family instead of natural gas coming into our house. There's no question that our energy systems in 20 years or less will look nothing like they do today, and I think there's a bright future ahead of us. With regard to broader sustainability, I think there's so many important issues that need to be worked on that every one of us can pick an issue that we're passionate about it, get to work, and we can all remember we vote with our feet, we vote with our wallets, and we also need to vote with our votes. So get politically active and let your leaders know what's important.
I just really want to say thank you to everyone for being part of this discussion, and thank you to Steve very much for hosting this.
Thank you very much.